Today we're going to be discussing transformations of quadratic functions. So there's a couple of definitions that we need to make sure that we understand before we get started, starting with a parent function. So a parent function, I like to explain it as the base equation for any type of function. That would be a linear function, a quadratic function, absolute value, any function that we've discussed or that we even haven't has a parent function. So each function family has a simplest equation. So it's a base equation, it's the simplest equation called a parent function. And so for a quadratic, so the quadratic parent function is y equal to x squared. Okay, that's our base equation that we're going to build off of for any other quadratic function. It starts out as y equals x squared. Transformations are changes that we make to that parent function, changes in size or position that are made to a graph, such as rotating, flipping, sliding, stretching, etc. There's a lot of other ways that we can transform something. That's just kind of a few ideas to give you a starting point. So transformations are ways that we change that original parent function. So when we're working with the transformation of a quadratic function, I find it that it's often easiest to work in the vertex form. And if you remember, vertex form is y equals a multiplied by x minus h squared plus k. And I find that easiest because h actually represents the horizontal movement. So it's easy to see from y equals x squared where we moved left and right. The k represents the vertical movement, so we can very easily see how is it shifted up and down. And a represents the scale and position. And we'll explain that a little bit more here in a minute of the parabola. Okay, so when I'm talking about h representing the shift in the horizontal movement of the parabola, what I mean by that is if h is a positive value, the parabola shifts to the right that many units. And if the h is a negative number, then the parabola shifts to the left that many units. So if I had x minus 2, remember that 2 there is actually a positive number, so it's going to be moving, that parabola is going to be moving to the right value. So remember to be careful about the h value because that vertex form has that subtraction sign. It does make that a little bit tricky, so just make sure you keep that in mind. Okay, so along with the horizontal shift, the k value works the same except for it's a vertical shift. So if the k value is a positive, it's going to shift up. And if it's negative, it's going to shift down. So just think about your number line. Left of the 0 is going to be negatives. Right of that 0 is positive numbers. Down from the 0 is going to be negative, and up is going to be positive. So it kind of works the same way with the h and the k value. Okay, now the a value, I promised we would talk a little bit more about. A is the scale and position. So if a is negative, we've already talked about what happens. What that means is the parabola opens down. And so when we're discussing that as a transformation, it means that the function is reflected, which is another word for flipped, across the x-axis. So it's reflected across the x-axis. So that's where we talk about the position of it changing with that a value. If it's a positive number, it's going to be in its original location, but then if it's a negative number, it gets flipped to be reflected over the x-axis. So that's part of what the a-value does. The other part of what the a-value does is that it gives us a scale factor. And so if a is greater than 1, if it's a number larger than 1, then that means that we're taking that and vertically stretching it. It's taking that parabola and it becomes vertically stretched. If the number is between 0 and 1, not equal to 0, not equal to 1, but anything in between that, so a fraction there, the parabola is what we call vertically compressed. And if it's equal to 1, then it's going to be scaled the same as the parent function. It has a scale of 1. Okay, and so here's kind of the vertical stretch and the vertical compression can kind of be a little bit tricky if you're unsure about those. But what I like to think about is vertical means up and down. So think about having like a ball of Play-Doh or something. And if you take that ball of Play-Doh and you stretch it vertically, straight up and down, you notice that that Play-Doh is going to start to become leaner, and it's going to kind of become skinnier because you're stretching it. And so when you have a value that's greater than 1, your parabola kind of becomes a little bit skinnier and it becomes stretched. Whereas if you take that same Play-Doh and you squish it down and you compress it down, it becomes fatter. And the same thing if you have a parabola that is a fraction, that a value is a fraction, it's going to be compressed. It's going to kind of become wider than the original parent function. So sometimes that helps me just kind of think through that, give you an idea of something to think through. So one example here, just to show you the parent function in comparison to a transformation. So the parent function, y equals x squared, the vertex of this is at 0, 0. A lot of times the origin is kind of your starting point for any parent function. And so that means that right here is my vertex, 0, 0. The reflection, there is none. Okay, it's a positive a value, so it's opening upwards like it should. The location, it is centered on the origin. And as far as scale goes, it has a scale of 1. Okay, it's at its base form. Your x-intercept, y-intercept all happens at 0, 0. You have this scale value of 1. Everything's kind of centered. It's a very base, simplistic parabola. Now, if we look at this transformation, we start to look here and we notice a couple of things. So first off, our vertex is going to be at 4, 9, based on that h and that k. Well, if the h value is 4, a positive 4, then according to our transformation here, a positive number, it should move to the right 4 places. And so if you look at my parabola, here was the center point. Now it has moved over here 4 places to the right. So that's one transformation that's made. Then 9 is our k value, and it's a positive 9, so the parabola has also shifted upwards 9 units. So what you notice is originally my vertex was at 0, 0, and now that I've done this transformation, it has moved to the right 4 places and moved up 9 places. Now my vertex is at 4, 9. And so that's a change that has happened in this parabola. Then we notice that I have a -2 value for my a value. So that negative means that this has been reflected over the x-axis, meaning it has been flipped upside down. Now it's no longer opening upward, it's opening down. So this is a reflection over the x-axis. So it would have here been flipped upside down, then we would move that vertex to the right 4 and up 9, and that's how we get to this position over here. Now, as far as location, it was centered here on that middle part, and then we discussed how it has shifted 4 to the right and 9 up from the origin. And as far as scale goes, if you look here, this is a +2, and it's a little bit difficult to see in the parabola just because it's not a huge change in the scale, but this as being 1 and this as being a 2, you notice it's a little bit skinnier, so it's actually been stretched just a little bit. So the scale here, it's vertically stretched. by a factor of 2. Okay, and so that's what the basics of a transformation looks like with quadratic functions. And we will practice this a little bit here soon.